happens when you are building a startup? There is work-life balance or things like that. Very difficult to achieve, but your focus is to develop a product which can reach out to mass developers. What our next speaker is going to introduce you. Basically, that guy is building. Okay, has anyone used Android Studio? Great, Harshad. What is the most painful part while using Android Studio or setting it up? Builds? Okay. Does your system hang?
Yes.
Okay. It is becoming faster, but yes. So I'll tell you from my experience. I did a project on Android at my internship in college, wherein we were using Eclipse. And I had this old Fujitsu laptop. Whenever you used to fire up the emulator, pehle pankha chalta tha laptop. Then a screen appeared, right? We have come far along. What is the future? I guess the future could be when it runs in the browser itself, kahin aur cloud pe hosted hai. That is what single-handedly our next speaker coded, and he's going to talk about ARM programming. He's the founder of Morefficient, and his name is Harshad. Please welcome Harshad.
Yeah, thanks, Arpan.
Okay, before that, can we have a louder round of applause?
Right, so I work mostly with PDF, so my tech is a PDF and you scroll through it as things go. So anyway, before we begin, quick audience poll: how many people are students? How many people are students? And professional programmers? Okay, cool. How many have heard of ARM VMs? How many have deployed something to an ARM VM? Raise your hands, please. One. Okay, cool. Yeah, so you'll know some of the problems that I run. Okay. Right, so why ARM? So ARM is a family of microprocessor instructions that sometimes offers better performance per watt. And in general, you can reduce cloud costs by up to 40%. We internally have got them to about 50% lower, but depends on your workload. Challenge is that it is not binary compatible with your Intel laptop. So you have to compile something to run on ARM, and all of your libraries have to run on ARM. And God damn it, I've been told I can't curse, so I might go quiet for a while. Could you scroll down a bit? I'm not controlling this. Right. Some real numbers, but again indicative because they depend on database usage, disk usage, network, and so on. So typically, if you just look at VM costs in AWS Mumbai, it's about 40 to 50% forwarding or VMware's various iterations. But all of them suck, and all of them are restricted to niche use cases because the lag is really high. With our product on like even a moderate internet connection like a 4G network, you don't feel as if it is running remotely. Okay, next slide please. This is painful. So as an example here, I have Android Studio, which is gotten pixelated for some reason, and which you can try out on this website free for now. You'll get 4 cores and 8 gigs of RAM and better builds than most of your machines. And next slide please. Yeah. Okay, next slide is, scroll down, yeah. We also have an equivalent sister product called Inbox, which runs emulators in the cloud. So this is more on the testing and QA side, and we can offer better in ways that matter than other people like Genymotion and also Firebase. Okay. Right. So where we come into the picture, where ARM comes into the picture. So one is that we provide ARM environments, so you can boot up IntelliJ or PyCharm with Java and Python configure that is running on ARM. So if you have a Python project that you want to deploy onto ARM and you want to see first whether it works, what sort of performance it has, you can do it immediately right now. You have to do zero setup. Open the project, load your repository, and test it. That's one reason why I want the ARM market to develop. Another important reason is that all of our infrastructure runs on ARM. Next slide, please. So this includes the auth servers, which go for your user authentication, global scheduler. So Kubernetes is not a valid abstraction for our use case. So we have to write our own Kubernetes. So that caching servers, including things like KDB, which is an enhanced version of Redis, CDN, bug tracking, analytics, everything runs on ARM. And we're able to achieve this largely because the toolchains are already available. But then the question becomes, toolchains are available, some libraries are available, things are generally performant, still very few people are using ARM. And why is that? Why isn't ARM, it seems like an absolute no-brainer, being adopted more readily in the market? This then comes down to the challenges and what we have to do as a community. Next slide, please. Right, so my images are getting removed. Scroll down, please. Right, so no, scroll up. Yeah, so like I said, in transitioning from Intel or x86 in general to ARM, toolchain compatibility is not really an issue. So your GCC works, Clang works in general, Python, Java, Rust, all compile and we provide options. Bazel, I don't know, has anyone used Bazel here? Okay, it's a build tool from Google, excellent, but mostly works. There are some works here and there that you have to navigate. Docker works really well. So again, toolchain compatibility is not an issue. So to understand the problem, we have to take a broader view on technology. Is it stable? Will it perform as fast? What are the migration costs involved? Will my libraries work and so on? So beyond just toolchain compatibility, we have to focus on three other aspects. One is industry, second is mentality, and third is in terms of distribution. So easiest to understand of these is distribution. So usually if you have a Python library or a Node.js library, they will often have a native implementation so that your performance is good. So this happens with almost every deep learning framework. It happens with almost every web server. So Python, for example, has ccardet for HTTP parsing and UV loop for the event loop and so on. So the question with distribution is, are the binaries available for ARM? And in general, the answer to that was maybe. And this wasn't clearly mentioned on a lot of prominent frameworks, and I'll come to this. Second is in terms of mentality. So ARM being so new, it is not a part of the solution space that most people think about. So when this large company CTO asked me what is ARM and how is it different from AMD, whatever. And third is in terms of industry. So in terms of industry, again, basic questions. If I have a DevOps pipeline, will that work on your fancy server, on your fancy thing? If I am building this native binary, will this be able to compile over there? If I have source code, will this run as fast over there or not? What are the performance implications? Again, generally, we didn't know this. And all of these factors led to the perception that the migration cost of moving from Intel, where things in general work, onto ARM would be higher than the actual infra savings on ARM. So even if my ARM server is 40% cheaper and I would save $40, the migration cost might be $80 and make the whole thing pointless. And this uncertainty is what I think is hindering the broader adoption of ARM. This manifests in companies in different ways. So if you are a seed stage company, so I come from the startup world, so I think in these terms. If you are a seed stage company, your general costs are low. So let's say your monthly hardware costs are $200 a month. So over here, going from $200 to $120, the $80 delta is usually not enough for you to focus on an unproven technology stack. Where what you want to do is first establish product market fit and get the next round of funding. And you can do that by burning a bit of money. Once you get to a growth stage, you are usually swimming in VC cash. Amazon will give you 100K, Google will give you 100K, Microsoft will give you 100K, and you're not really thinking of cost optimization. And it is during this time that all of the standard processes get put in place. And when you become a unicorn or let's say a $500-ish million company, then things work, you have 1 million or so customers, you become conservative. And it is really hard for you to transition into something new without having concrete answers. And because it is hard for you to transition, you need to do a long study of whether this transition makes sense, which is again expensive, which again hinders adoption. So it creates a vicious cycle. And there is really no way around it from a purely technological basis because technically the problem is solved. It comes down to perception and mentality. So how do we solve this? The general theme of the solutions is that we have to bring the activation energy of the transition down to a point where it becomes easy to evaluate. By activation energy, I mean that how many remember chemistry from 11th? Not too many. Okay, so let's, by activation energy, I mean that let's say that right now you are over here, eventually you will come down to here, but the path is from here to here. So there is a hill that you have to climb to get to a lower energy state. This hill is what hinders adoption. And even though at the end you'll be better off, just the sight of this hill prevents you from actually climbing it. So we have to find ways of bringing down this activation energy so that it's trivial for people to evaluate whether this thing makes sense or not. So to do that, first thing we need to do is basic README batches on your major GitHub projects. So in the browser world, there's a website called Can I Use, which tells whether some particular feature like a shared state worker will work on some particular browser, like Chrome 100. But the matrix of libraries and versions is far greater than the matrix of browser features and potential browsers. So even though there's something equivalent for ARM, that's not really good enough because the website will be too big. Another major problem with Can I Use for ARM is that ARM is not a part of the solution space that people are thinking about, as I mentioned. So we need to have README batches over here, and that has been validated. We can help with the validation if you deploy it on if you build it on our thing, but that's secondary. One thing that we will be providing very shortly is a one-click evaluation for ARM. So let's say that you are a video streaming SDK provider. Like you have some SDK that has a client Android library, and on the server side you have something for admin. And you want to test whether this Python SDK will work on ARM so that once you scale up to 1 million users, you can halve your costs. And you want to test whether this runs on ARM. Today, if you have to do it, you have to spin up an ARM server, you have to compile Python for that, you have to download the library, you have to do a full performance test and so on, which again increases the cycle time to the point where it becomes impractical. What we have to do as a community is build it, is to bring the technology to a point where it works with one click. And we'll be doing that, but again, we need people to build the infra, to use the infra that we provide. So that is coming soon. Second thing is that we need validated first-party binaries. So this comes down to the distribution issue. So Cypress, until recently, did not have ARM binaries. So we had a big customer in May who wanted to build a JS testing pipeline on our platform because their laptop was hanging up because Cypress is a big heavy application. And they weren't able to do it because ARM binaries were not available. Until earlier in September, TensorFlow binaries were not available. Now they are. So we need more of this. We need these things to be validated by first party. Even today on TensorFlow's website, they say that it is fast and equivalent to ARM. It's Intel. But again, I have to take people's word at it, which is usually not good enough if I am a senior person in a large company, because I have other things to worry about. And this infra thing is usually not top of my mind. We need open source reproducible benchmarks on real world projects. This is taken from some Google website, not this please. Apple is the worst at it, Amazon is not great, Microsoft is not great, but this is a Google event, so I thought I'd make whatever iota difference I can. But over here, this is some obscure benchmark running on some obscure workload on against two vendors that I do not know what they are. So this is completely useless to me if I am evaluating whether I have to make this transition. So I don't know how this translates to the performance of my web server, of my caching server, of my build server. I do not know that if I move my Node.js server from Intel to ARM, will my performance go down from 156 to 100%? I don't know. We need open source reproducible benchmarks. Another major benefit of having these open source benchmarks is that if tomorrow I want to test my workload, all of the boilerplate stuff will have already been done. So it becomes easier to drive adoption. Right? So again, this is something that we are trying to do internally, but it has to be a larger effort from the community. The silver lining of this is that the technical problems have been solved, so it comes down to more evaluating stuff. But again, another problem with having benchmarks like this is that they do not take into account the duty cycle of your actual workload. So let's say I have a web server that is running on some hardware, let's say 1 core 2 gigs of RAM, and my current utilization is 10%. Tomorrow, if I see an ARM server that offers 60% of the performance at half the cost, then this is a valid substitution because I will need only one ARM server to directly transplant the workload. But if my duty cycle right now is 70%, then 60% workload, 50% cost, it makes no sense because now I have to provision 2 servers anyway. So to have benchmarks, we need those benchmarks to be calibrated against things like duty cycles, actual workloads, and so on. And again, these have to be open source and transparent so that you can actually check that these things work. And finally, we need to have codified experience. So Google and Amazon and Microsoft now are releasing ARM servers. Presumably, someone has put in the effort to make the transition. Otherwise, the $100 million investment would not be worth it. So instead of having like marketing blurbs that are already present, we need to have detailed case studies in terms of how we do it, and again, talks like conferences. So this hopefully goes some way towards it, but broadly comes down to community engagement. So yeah, thanks. Questions we can get it.